Hello, thank you for watching this video. So in this video, we're doing question 8 of November 2021 question paper mathematics paper 2. The topic is trig application or 3D application of trigonometry. As you can see these shapes here. So let's go. In the diagram below, T is a hook on the ceiling of an art gallery. Points Q, R, and S are on the same horizontal plane from where three people are observing the hook T. The angle of elevation from Q to T is X. Let me repeat this thing again. In the diagram below, T is a hook on the ceiling of an art gallery. Points Q, S, and R are on the same horizontal plane from where three people are observing the hook T. The angle of elevation from Q to T is X. The angle S in triangle QSR is 90 plus X, and angle R in triangle QRS is X, and the length QR is 5 units, and TS is equal to SQ. Let's look at this. So, this is how I imagine this thing. You have a ceiling here, like you know the ceiling up here. This is your ceiling. And on this ceiling of yours, there's this hook here, right? So I imagine the hook to be this one here. So this is your hook at an art gallery. So we have three people, one here, one there, and one there. They are looking at that hook over there. So this guy here, his eyes looking there. Here's this guy looking there. Here's this guy is looking at that hook. No problem. So I think I left something this here. So here is what they are saying now. They are saying now, the angle of elevation, right? Which is, what is the angle of elevation? So is the angle of elevation is an angle measured from the horizontal, right? Up into your ray, right? Or into your line of sight. So in this case, Q, S, and R are on the same horizontal plane, which is, they're on the same level. That's what they're saying. It's more like, they're like this. If you look at this paper, I'm holding it this way. This corner, this corner, this corner, this corner. They're in the same horizontal plane. So this paper, can think of it as a plane, right? So if you think about the corners of this paper, they're all on the same plane. So which is on the same height of some sort. So these 3 points there are points that are lying on the same, with this guy, or the point S, the point Q, the point R, are all lying on the same plane. That's what they are saying. They are all lying on the same plane. Not a problem. So this Q is looking there, S is looking there, and this is looking there. So if you have a horizontal here, this is a horizontal. Your angle of elevation is the angle measured from the horizontal, right? It's measured from the horizontal into your line of sight. This is your line of sight, or you can just say it's your ray. This is the angle of elevation. So in this case, Q, S, and R are all horizontal like this, right? And then now, if Q is in the corner here, Q is here looking at Q is here looking at that hook over there, right? So the angle from this horizontal to the line of sight, or the line joining T and Q, is what you call the angle of elevation. So it's a situation like this. Your Q may be sitting here and your T is there. So since this is the horizontal, the measured angle between the horizontal and the line of sight where Q is looking with his eyes, because where the direction in which Q is looking is the line of sight. This angle between the horizontal and the line of sight is called the angle of elevation. That's what it is. So this angle here is between the horizontal and exactly where his line of sight. So it's a situation like this. Or maybe if I were to orientate myself this way, the horizontal is like this, his line of sight is like that. So this is the angle of elevation. The angle between, which is this angle over here. So here's the horizontal. This angle between these two planes is angle of elevation. Is the angle measured from the horizontal into your line of sight or to your ray, which is a straight line. That's the angle of elevation. No problem. They went on to say the angle S on angle S, which is that angle there, on triangle QSR. QSR is this triangle, is this triangle on the base. So QSR is the base of this triangle. It's these points that are on the same horizontal plane. So QSR is a triangle formed by those points that are all in the same horizontal plane. So all these points, you can think of them all in the same level. So which is that the triangle formed by those points that are all on the same level. Angle S in that triangle is called 90 plus X, where I would think your X is an acute angle. Right? Not a problem. Your angle R, where is R? R is here, of triangle QSR. Where is QSR? QSR is also the angle in which have three points that lie on the same horizontal plane. So this angle here, formed by the triangle which is at the base, let me just say the base of this, the floor. This triangle here, which is this navy triangle, they're saying now the angle between line QR and RS is equal to X. That's what they're telling you. And then they want them to say that the distance QR, which is this distance here, is equal to 5 units. Not a problem. And then they told you that TS is equal to SQ, which is TS, the distance between this guy and that guy, because these are two people. QS, the distance between these two guys, and TS, the distance is a distance between your person, where your person is, and your hook T. So QS is this distance here between the person, from the person to the hook T. So they're saying the distance from Q, from this person Q to the other guy is equal to this distance from the other guy to that hook there. So you can say T and Q are equidistant from S. They're equally distanced from S. This is another problem. So let's try to go forward. 8.1. Okay, so now we're doing 8.1. 8.1 reads as follows. Prove that QS is equal to 5 tangent of X. They wanted to prove that QS is equal to 5 tangent of X. What is QS? QS is the distance between this person here and that person over there. That distance is QS. So they want us to prove that the distance between these two guys is equal to 5 tangent of X. The distance between Q and person S. Not a problem. So how to approach this? So you need to think about QS that you want to find. QS lies on this distance, this line here is shared by two triangles. This triangle here and this triangle over there. So I'm going to write these triangles, both of them. I'm going to use a red ink. So let's look at QS and see where it is. QS is on this is here. So we have QS looking like this first. The first QS looks like this one here. So I'm drawing this triangle here. And on this triangle, we have T up here, right? And what do you have? You have Q down here, which is this, and you have S down there. And then you have this angle over here. And we're told that this is equal to that. I've drawn this triangle here. Here is it. This is where we first see QS. The other triangle in which we see QS is this triangle, the base triangle, the one that I've shaded here. So, if you look at it, all of this side, so this base triangle, it looks like this. Looks like this. So you have Q, you have S here. You have Q, you have R. And what do you have? So you're also given that this is 90 plus X, right? and you are given that this is equal to x, and you are given that this is 5 units. So if you're looking at both of these triangles, you want QS this side or this side. Can be QT sorry. If you're looking at this triangle, you want QS this distance or that distance. This is the same length, because if I can just connect them like this, if I can move this one to join it here, it will look like this. It will look like this thing here. If I were to maybe move this one to this position here, it was going to look similar to this one. Not a problem. So you want QS here, which is the same as the QS over there, right? So how do you go about this? On this triangle, you only have one measure, which is the angle. You don't have any side. So there's nothing much you can do with this triangle. But if you look at this one, that also contains QS as well. You have a side, you have an angle and an opposite side. You have an angle and you have an angle and a missing side. And the side that is missing is opposite to your angle that you are given. So this triangle looks much better than this one. Because here you have an angle and its opposite side, you have an angle. You are looking for its opposite side. So you can use the sine rule here, right? So, which is, what is the sine rule? You say sine of A over small a is equal to sine of B over small b. Not a problem. So in this case, what do we have? We have we have QR, right? We have QR, which is this distance here, which is opposite S. So this should be small s, and that should be angle S over there. So you say, okay, sine of angle S, which is this angle over here, divided by small s. This side opposite, the angle S will be small s over small s, is equal to R, angle R, that is small r over there. So it should be sine angle R divided by small r, or lowercase r. And then what you are left to do, because this is the sine rule, just substitute things that you have. What is angle S? Angle S is 90 plus x. So you have sine angle S, which is 90 plus x, all divided by S. What is your small s? Is your length, opposite length, which is 5 units. So it should be 5 units is equal to sine angle R. What is angle R? Your angle R is equal to x. So it should be sine angle R over small r. Small r is the opposite length, which is QS, which is what you're looking for, all over QS. Then from here, just solve for your QS, cross multiply. This times that, you'll have QS times sine QS, which is this distance over here, times sine 90 plus x is equal to, this times that, it should be sine r. What is your angle r? Your angle r is x, so it should be sine x here. What is the mistake? So this should be equal to 5 sine x. Not a problem. You divide by sine 90 plus x. You divide by sine 90 plus x. So this and this go away. So your QS is equal to 5 sine x over sine 90 plus x. Not a problem. So now you have to simplify this. What do you do now? To work with these things, you know that you must have you must know this kind of situation here. 0, 90, 180, 270, and 360 here. So your x values, your angles here, are less than 90, but greater or equal to 0 degrees. And these angles are less than 90 degrees. These are x less than 9, x minus 90 minus x, that acute angle. This side, they are greater than 90 degrees. They are less than 180 degrees. Here, they are greater than 180 degrees. They are less than 270. Here, right? there, they are greater than 270. They are less than 360. Right? And you know that here, sine x, cos x, and the tangent of x are all positive on the first quadrant. On the second quadrant, only sine x is positive, all others are negative. Only sine x is greater than 0. On the third quadrant, your tangent of x is greater than 0. On the fourth quadrant, only the cosine of x is greater than 0. Not a problem. So you ask yourself now, once you finish this or you know this, where is 90 plus x? 90 plus x is on the second quadrant, right? What sign is your sign there? So let me do this. You say, okay, qs is equal to 5 sine x, right? Over, no problem. Let's simplify this part now. Where is 90 plus x? 90 plus is on the second quadrant. What sign is your function there? Sign is positive there, so we'll put positive. Put positive here. No problem. Sign is positive. But then if your maximum here is 90 or 270, if you have your maximum, this number here, this is your maximum. If your maximum is 90 or 270, which is this one or this one, a function changes to its cofunction identity. And this, because the sign is going to change to its cofunction identity, which is cos. So this will become what? Positive cos x. And you know that sine x over cos x is tan. So your qs is equal to 5. This over this is tangent of x. This is it. We've proved what they wanted us to prove. We proved this. So now we know that qs, which is this distance over here, is 5 tangent of x. Right? Not a problem. And this is equal to that because we were told that they are equal. Because we were told that ts is equal to sq. Sq is this. So ts is equal to sq. So if you know what this is, you know that as well that this is also 5 tangent of x. You are given, you're told that they are equal. So you found this, you also found that as well. So in that case, here's what you have. You have that your qs is 5 tangent of x on this triangle, which is on the base triangle, which is this. Even though that one is 5 tangent of x, as same as this one, 5 tangent of x, this side. This side here. So this is s, this should be 5. 5 tangent of x. And yeah, that's where we are. And okay, let me stop right there. Okay, not a problem. Let's continue to the next question. Okay, so now we're doing 8.2, right? 8.2 reads as follows. Prove that the length of QT is 10 sine x. So they want us to prove that the length of QT, which is this length over here, is what? Is 10 sine x. So here's QT. And QT is also that length over there. Right? So I'll redraw this triangle on this side. So QT is only on this triangle. It's on this triangle over here. On this triangle, TSQ. Right? So what I'll say in triangle TSQ. So and then draw the triangle. TSQ looks like this. Let me use the same color so that you can be able to recognize it easily. Here's it. Here's it. And then maybe something like this. So this, I'm trying to draw this triangle over here. Maybe it doesn't look very similar. Let me try. I'm struggling to draw these things. I think this looks better. This is T S. Actually, it's T S Q S Q. So it's this triangle over here, right? So from the previous question, which is 8.1, we were calculating QS. We found that QS is 5 Actually, this is equal to that. We call that QS is 5 tangent of x, right? And now ST, which is this distance here, is also equal to this, because we're told that ST and QS are equal. So we found QS is 5 tan x, QS is 5 tan x, so ST is also have to be 5 tangent of x. This is not a problem. Done. So we have the length of the side. We're also given that angle over there. Angle Q, which is this angle over here. We're told that this angle is what? Is x. We're told that these two sides are equal. So if these two sides are equal, right? And this side is equal to that side. You have an isosceles triangle, right? You have an isosceles triangle. So if you have an isosceles triangles, you know an isosceles triangle is a type of triangle that have two equal sides and two equal angles. So if these are equal sides, then these will be equal angles, because these are angles that are opposite equal sides. This angle is opposite that one, and this angle is opposite that one, right? So this angle over here, this one, should also be x. Why am I saying this? Because these are angles opposite equal sides. Because this angle is opposite that side, and this angle is opposite this side, and this side is equal to that side. So this angle should also be the same, right? And the angles of a triangle add up to 180 degrees, right? So this angle S, so your angle S plus angle Q plus angle T, they should all add up to 180 degrees. Why? This is sum of angles in a triangle. You know this, right? So your S is what you're looking for, that angle S there. Plus Q, angle Q is X, plus angle T is X, it's equal to 180 degrees. You'll find that your angle S is equal to 180 degrees minus 2x. So here, we have 180 degrees minus 2x here. This is 180 degrees minus 2x. So what you're looking for? You're looking for this side here. QT. You use the same sine rule as well, because you have an angle, you're missing a side. You have an angle, you have that side. You have an angle, you have that side, which is easy. So what do? We can say, okay, use the sine rule. Sine angle S is equal, sine angle S over small s, right, which is what we're looking for, is equal to sine angle Q over what? Over small q. So sine angle S is what? So it's 180 minus. So it's going to be sine of 180 minus 2x all over small s. What is small s? Small s is QT. What we're trying to prove is equal to sine angle Q. Where is angle Q? Is this one, which is sine x over Q. What is Q? Q is 5 tangent of x. Q is 5 tangent of x. That is what you have. So what we're left to do now is to solve for your QT. But I need some space. So I'm going to clean here and here so that we can continue that work. So let me clean. Okay, now so we'll continue with 8.2. We stopped there, right? So you have sine 180 minus 2x. So you ask yourself, where is 180 minus? 180 minus, where is it? 180 minus is on the second quadrant. Here is here. What sign is your function there? The sign is positive, because sign is positive on the second quadrant. So you have the sign of that 2x. So because your maximum 180 is on the horizontal, your function will not change to a cofunction. Your function changes if your maximum is along the vertical line. So what we have here, 180 minus is on the second quadrant. What sign is the function sign there? Sine is positive. So you just have sine of 2x divided by what? Divided by qt is equal to sine x over the tangent of x. Then cross multiply. This times this, we have a sine 2x tangent of x is equal to this times this qt sine x. That's what you have. Then what you need to remember now is that this is a double angle identity, and this is, you know what this is. You know that. Let me just write it maybe somewhere. Let me write it maybe somewhere here. You might remember that sine 2x has this identity 2 sine x times cos x, right? And the tangent of x is equal to sine x over the cosine of x. This is how we derived time from the previous question. Sine x over cos x. So what we have here, we have this, which is what? Which is 2 sine x times cos x. This is that times the tangent of x. What is the tangent of x? The tangent of x is equal to sine x divided by cos x is equal to qt times sine x, which was on the right hand side. So you'll see that this and that go away. So on the left hand side, you're left with 2 sine squared. 2 sine squared x is equal to something is not okay. We should have had a 5 here, right? Which means we're supposed to have a 5 here as well. Let's say 5 tangent of x, which means here we should have had 5 sine x over cos x. So this still cancels that. So from this stage now, we have 2 sine x, right, times 5 sine x is equal to qt times sine x. Because we want qt divided by qt here, divided by sine x, you divide by sine x here as well. This and that go away. You're left with what? Qt is equal to this and that go away. 5 times 2 is 10 sine x. Here is it. We found it. Because this was supposed to be 5 times x there. But we made a mistake. So we rectified that. And this looked like what we wanted. They wanted us to prove in the first place. Here is it. So we're good. No problem. Now we're going to go to the last question, 8.3. Okay, so now we're doing the last question, which is 8.3. So they are saying, calculate the area of triangle TQR if angle Q of TQR is 70 degrees and X is 25 degrees, right? So they want us to find the area of triangle TQR. Which triangle is that? TQR is the face of this triangle, right? It's this triangle out here, the bigger triangle. So let me try to draw it. So it looks similar to this. So this is this big face here. So this is Q, this is R, right? And then you said this is T. So what do you know? You know QT, because QT is 10 sine X, is what we just proved here, QT. This is 10, this should be 10 as well. It's 10 sine 25. So what is 10 times 10 sine 25? It's 4.23. So this distance is 4.23. So we know what this distance is. It's 4.23 units. So the area of this triangle, TQR is equal to half of this size, sine of the included angle. So it's sine of half QT times QR, sine of the included angle, which is Q, right? So your area will be half of 4.23 times 5 times sine of Q, which is 70. Therefore, the area of triangle TQR is equal to the answer of that, which is 0.5 times your answer times 5 times sine of 70 degrees, which is 9.93 square units. So this will be your area of this triangle, because you know, if you had this side and this side, it's going to be half of the side times the side times the sine of the included angle. If you had that angle there, it's going to be half of the side times the side times half times sine of angle, included angle, which is T. And I hope it does make sense to you as it does to me. Thank you for watching. Cheers.